covered all of my slides in the group number 5, which stopped with the estimation, and we still need to discuss prices, but in order to discuss prices, we will need a wage variable, which is not there, so go to back later. In my slides number 6, it's something we already did before the lunch break, which is how to simulate the model over the sample and check the outcome comparing the simulation to the data. And what we want to do next is to verify how the model reacts to shocks. So in eViews, what I usually do is, not sure whether I have a code already available. No, so let's do a code. So here we have obtained the simulation for the historical values. And if we want to evaluate the multiplier of the model, we can do this by running a shock in the past, which is not the best way to go, but it's simpler to show you how to perform this in eViews. So our model is called MSFC, if I'm not wrong. And the code will be MSFC dot, and then we need to select what is called a scenario in eViews. Now, the scenarios can be obtained by opening the model object and going to scenarios. And basically, when you start, you have the baseline, which associates the solution to variables with _0, and scenario 1, which adds _1 to the solutions. And we can have other scenarios, 2, 3, 4, but that they have to be created before we use them. So here we already have scenario 1 available. And there are different ways to shock a variable. One is to use the override command. The override is telling eViews that the following variables will be taken from the scenario rather than from the data. So we know which variables are exogenous. So the main fiscal variable is GT. So we can try the first simple shock to government expenditure. So now eViews expect to have a variable GT1, GT_1, and one way to create this is to copy GT, the series from the data, to this new variable GT_1. Then we want to select when and how to shock our variable. So we can set the sample to, now the simulation sample is 2009, I think, something. So let's shock in the first quarter of 2010. And we want to decide what type of shock we want to give. So this will depend on which variable we are shocking. Now, GT is the value in million pesos of government expenditure. So if we want to do a standard Keynesian shock and we want to shift government expenditure up, then we can either increase government expenditure by the same amount over all the following periods, or change its growth rate. It's simpler to do the first option. So at last means the last available quarter. Over this period, we want GT minus 1 to be greater than GT by the size of the shock. So we can look at GDP to decide the size of the shock. And GDP of Mexico in 2010 Q1 was this number here. So I can copy this value, paste it in here. So this will be 100% of GDP. So if I move the decimal here, this will be 1% of GDP, which is reasonable for a fiscal shock. Then I need to set the sample back to whatever we were using before. This was in my program number 4, which is no longer open. So the sample, the simulation sample was 2009 to third quarter of 2021. So I need to use the same sample for my simulation and then use smfc.solve to obtain a solution. So let's run this program. And now I have, as you can see in the work file, I have _1 for all endogenous variables. So I can look at the outcome on GDP. And well, maybe it's easier to look at the ratio of the simulated GDP after the shock against the baseline. And I can subtract 1. So this is telling me that the model has an impact multiplier of 1.58. So multiplier is larger than 1, as I would expect. And then the long run multiplier is smaller than the impact multiplier. Now, this is not necessarily the true value of the long run multiplier. Why? Well, because these are numbers in current prices, and I gave a fixed shock at the value of 2010. So this shock will be decreasing in size as inflation is positive in the following years. It will be a smaller and smaller fraction of GDP. So if I compare the size of my shock to GDP in the baseline, this will be decreasing. So this is the type of shock I've given to the model, and therefore it does not mean that the long run multiplier is smaller than 1. Okay. Anyway, this is how I evaluate the shock, and I can track what are the outcomes for other variables. So I can see what is the impact on imports. For instance, given that imports are endogenous, and obviously we have an increase in imports which is larger than the impact on GDP, because if you remember, the income elasticity of imports was larger than 1, so imports increase more than GDP. So we can look at what happens to the minus alpha W will be the balance of payments compared to the balance of payments in the baseline. And the blue one is after the shock. So we have a deterioration in the balance of payment, which is roughly stable for the whole of the sample. Okay. Now, how do we do this with BMETs? And BMETs has another feature, which I don't think eViews has, which is the matrix of multipliers. Now, I have looked at this for preparing the course, but not in great detail. So the matrix of multipliers, this mult matrix comment, takes a period for the shock, exactly as we did with the eViews. So here we had 2010 to 2021 third quarter. And then it wants to have the instrument, so the exogenous variables we want to shock, and the target, which is the variable on which we estimate the impact. So let me copy this to our 29 code. And this, I guess, can go down here. And let's see whether it works. Yes, it worked. And this will be my multiplier matrix. I don't like all these zeros. No, this has given me the matrix of the impact for everything. So what I want is the outcome for one variable at a time. I thought I would get this, but I'm not sure. No. No, it will give me the whole thing. So well, let's execute this again and look at the do you know why this is scrolling like crazy? I don't really know.
One suggestion.
Yes.
In general, it is not. But when I've tried to experiment also working with a console to the right, so that you always see what you're doing and the output to the right rather than magnifying and minimizing.
The output to the left.
Yeah, to the left, to the right depends. So I think you can adjust that.
Mm-hmm.
And on the one hand, you have the code, the script, the source code, and on the other one, you have the output. Because the other things are on the right are taking a large portion of the screen, but then they don't change that much.
Okay. So how do I do that? I just
there is this 4 to the right. There is like an icon with 4 squares inside on the second row. Next to add-ins. And now a little bit more to the left. Left. Add-in.
oh, here.
Yeah, not this one. Yeah. Now you can.
Okay,
you can
console on right.
Yeah.
Okay.
And we can close this part below environment history connection. You can close it. You can reduce it like that or something.
In here.
Yeah.
Okay. So here I have the code, and here I have the console, and I can reduce this, I guess. Okay, but I really don't remember how I get the outcome of this only for one variable, because what I got here was the output of the multiplier matrix for everything, which is not so easy. So let's see what happens, what I can get from model. Multiplier matrix is what I asked for, but it's giving me too many outcomes.
Yeah, we have to look first to see which kind of object is this multiplier matrix, and then once you know.
No, I think the problem is that I gave a shock for too many periods.
Okay.
So the shock for period 1 is 1.56 is my multiplier, which is comparable to what I had in EViews. Yeah. And 1.54 would be the multiplier after one lag. Yeah. And then this is one after 2 lags, and so on. Yeah. But the output is a little messy to read when you shock the things so much.
I think we can show just the first column, because.
No, what I can do is to restrict this to 2010. 2010, say 4, and then this is going to be easier to read, and you give me the 4 multipliers, but like the impact: 1 lag, 2 lags, 4 lag, 3 lags. Obviously, I could take the outcome for, so let's call this GDP 1. I could take it from the simulated value of the baseline. Then I can modify the exogenous variable as I want, and then shock the model again and make the comparisons. But this is not, as I was saying, the best way to go for running these type of experiments. So let me save this as shock to past. What is better if to have a baseline solution also for the future, which we try to make as a steady state or steady growth solution. So how do we do that? Basically, in order to simulate the model for the future, we need to provide values for the exogenous variables. But before we do that, we know that we have an error in a residual between our simulation baseline and the data, which is given by the errors in our estimates. Okay, so when we want to do a projection, we don't want these errors to make our projection worse than it could possibly be, especially if our interest is to make a forecast for next year, next quarter GDP. Okay, so we want to eliminate the errors our model made in the past. And the way to do that is to compute some new variables, which are called add factors. And these are basically the residuals from the estimated equations. So if we add these add factors to our estimates, the estimates will become identities, because we add exactly the residual computed as the difference between the estimate and the data. So in eViews, we do this by going to our model and going to the procedures we can use on the model, choose add factors, and here I can choose whether to add factors to all stochastic equations only, so only the equations we estimated, or also to the identity. So this is why we use the add identity when writing the model in eViews, because it allows eViews to separate estimated equations from identities. So we usually do this only for the stochastic equations. When we do that, eViews will create a new variable for each estimated variable, adding an A as a subscript. So we have BP, which is estimated, and now we have BP underscore A, which is the add factor. But the add factor does not have a value yet. And in eViews, we also provide a value by using the model object, choosing add factors, and then set values. And this is how we can compute the values. So what we usually want is that equations has no residual when compared to actual values, to historical values. But there are other options that can be used in other contexts. So now that I've chosen this option, eViews should compute these add factors over the simulation sample. So let's see. And it has computed the add factors using the estimate up to the last data point. So now, if I simulate the model again over the sample, the baseline should be identical to the data. So if I now simulate the model 2009 Q1 to 2021, and now I look at NAFA-W, I was still using the scenario 1. So let me reset everything. Let me delete all the baseline solutions, delete all the shocked solutions. What else? Choose the baseline scenario. Let's check that I still have the adjustment, the add factors, and now I can solve. And I can look at my NAFA-W0, the simulated value, against NAFA-W, which is the historical data. And you can see that they are now identical. So I've removed all discrepancies between the simulation and the data from the sample. So now, to do a projection for the future, I will start with a model which is simulating the past perfectly without error, okay? And I have to provide values for all my exogenous variables. So in eViews, this implies that I have to take my model, get a list of the variables which are exogenous. So let me sort them by type. The blue one are the endogenous, and here are all my exogenous. And one by one, I have to provide future values. Now, how do we do that? What we do is to split the variables in different type. I do this with the next program, which I guess is number 5. No, number 5 is just the shock that we discussed. So it will be number 6, the last program I distributed. I'm not sure I've distributed number 6.
Mexico 6, yeah. Mexico 06.
06, yes. Okay, so you have it. So the first part is the creation of the add factors and the assigning values to the add factors. And then I create a group of add factors in order to visualize them quickly. So why do I need to do that? Now we only have 3 add factors, so let's look at them one by one using okay, so this is the error in my equation for the stock of bonds. And basically, the analysis I'm doing here is very important, and this is what I call the hidden secret of the modelers. What is the point? Now, this is a residual from an estimate. So we all know that it should be centered on 0 and distributed randomly around 0. So its best future value should be 0. So what we normally would do is to have at 0 as the future value of these add factors. But sometimes, as in this case, for instance, we have a shock or a structural break in the data close to the end of our sample. So here, the error of this MGSK is not so close to 0 for our last observation. So if we forecast the next value to be 0, we will be reducing imports by this amount for next period. Now, in some cases, this is perfectly okay. Maybe here it is perfectly okay because the error was negative in the second quarter, positive the third quarter, so it seems to be fluctuating around 0. In some other cases, this error may be large. For instance, we can do a simple experiment that just came to my mind, which could be very interesting. So let's we could simulate and estimate the model up to 2019 and check what the model predicts for 2020. In 2020, there was the COVID crisis. So we expect the model to be completely wrong, okay? In those cases, you will have these very large errors at the end. So in the end, you have to make a decision on which future values to put here. And you know, when I started, when I worked with the Confindustria, Confindustria is the Association of Italian Business, and they have a quarterly model of the Italian economy that I contributed to produce in 1990, a couple of years ago. And we used the model to make predictions for the next year or so. And in that case, obviously, they want the model to predict that inflation will be low because they use the projections to go to the table with the trade unions. And if they project a small inflation rate, they can ask for a low growth in nominal wages. And they want also, so this is how you play around with these projections. So that from a scientific, so to say, point of view, you can assign any value to this variable, which is within the standard error of your estimate. But if you assign a high value or a low value, it will make a difference to the outcome. So it's very easy for an experienced modeler to predict an inflation rate which would be 2.8 instead of 3.4 within the confidence interval of your estimate. So you're not cheating because you're using assumptions that are within the error, the simulation error and the estimation error of your model. But so from a scientific point of view, an inflation rate of 2.7 and 3.4 are not statistically different. But for the politician, they are very different because they imply a different path for the wages and different money that has to go out of the pockets of firms. Okay, so what usually happened at that time was that we produced our simulation assuming 0 for the odd factors, and we went to our with our tables to the boss, and the boss would say, no, this model is predicting inflation at 3.4, must be 2.7. So play with the odd factors until you get to the outcome that we think is credible. So this is how you usually proceed with these calculations. And now there are a number of other funny stories I could tell. The other one is that all the Levy models that we have prepared are based on the stock flow consistent philosophy, which looks at the medium-term, long-term stabilization of stock flow norms. And they are not thought for doing good short-term predictions. So we are not using the best possible forecast tool to guess the next quarter GDP growth, okay? And our counterpart, the counterpart of our policy notes are politicians and governments, and they don't understand nothing about modeling, econometrics, estimates. They do understand the number of GDP growth. So we have, I mean, I've been living for the last 15 years with this stress that I use tools that are not meant to provide good short-term forecast, but I am evaluated on the basis of my accuracy in short-term forecast. So our luck maybe is, or our ability is to produce also good short-term forecast with this type of models, even if we are not trying to do that as our primary objective. And again, most of the times we were good, and but also here you have to also always discuss with the others, because what usually happens is that I produce my projection for, let's say, Greece, and it's different from everyone else. So I have to justify why the OECD, the Eurostat, the Greek government, who have models run by many people, have a prediction which is different from mine, where I'm the only one to, do everything. And no, it's not so easy. It must be based on your your rate of success. So if you succeed, then you establish a sort of reputation, then they trust you. Otherwise, they just ignore you. You know, say, well, you do this, but those people running DSG models say that's going to be different. So why is your model better? And it's difficult to explain to someone with no knowledge at all about economics, econometrics, and modeling. Anyway, this is where you work with these add factors to try to adjust this solution in case something has happened at the end of your sample. And the next thing to do is to provide values for the exogenous. Now, we usually split the exogenous variables in groups, and we discussed this briefly earlier. So we have fiscal policy variables. So in the model, our fiscal policy variables are the change in equities, the change in foreign assets, government expenditure, pensions, rent on land, and the tax parameters. So what we usually do for serious projections for our country models is to look at the government agency. Now, usually most countries have a government agency which makes predictions on the evolution of public expenditure and revenue on the basis of current legislation. So in the United States is the Congress Budget Office, the CBO. In other countries are usually government agencies. So you don't want to make assumptions which are not official. So we take the numbers from them. Otherwise, we use some simple hypotheses, as I did here. So here we had EG. EG is the stock of government, or stock of equities held by the government. We have transformed this into difference. Now, if I take the quarterly difference in the equities bought, I have this highly seasonal variable. If I take the year difference, I take out most of the seasonality, and I see that this is rather stable with the exception of this large increase in 2018. So what I would suggest, what I would think, is that if for the future, the change, the annual change in EG should be rather stable. And this should imply, so this is saying that the value of the EG is equal to the value of the EG in the same quarter of the previous year. So it will make this continue to move as it did in the last 8 quarters. Or I could do something different. I mean, if I wanted to stabilize it at this level, I could have it drop first and then increase by the same number. DFG are the change in the foreign assets held by the government. And again, this is the total stock. So these are assets of the government, and now this has become a debt of the government with the rest of the world. Again, here I'm using the yearly difference and assuming that this will roughly stabilize or maybe follow the same path it has followed up to now. GT is the government expenditure, and this is in current prices. So this, as far as I remember, was not seasonal. Well, it's a little seasonal, but not so much. So this is the, yeah, this is also seasonal. So yes, I use the annual growth rate again here percent change. And this has been growing more or less at a stable rate. This should include the expected inflation rate because this is in current prices. So I said, well, the average here is about 5%, 6%. So let's assume it will continue to grow at an annual rate of 6%, 5%. Pensions, yes.
It's a lot.
It's nominal.
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 So if the inflation rate is, let's look at PPX, which is our price index, and the annual percent change is now 10%, 10% because of the, inflation is going up around the world. But before the inflation shock, it was 5.5%. So an increase in nominal government expenditure of 6% is almost zero in real terms. So it's okay. Pensions were growing much faster. So pension in the model include all transfers made by the government to the private sector. And the year percent change was around 11, 12%. So this is how the government is mainly sustaining the private sector. And I kept this 12% annual growth rate here. And then we have this rent on land, which I think is more stable in nominal terms. So I've assumed that this is not going to change. This is not seasonal. So I've used the previous quarter rather than the same quarter of the previous year. And finally, we have these tax rates. And since the tax base is seasonal, yes, they will also be seasonal. So again, I've used the same rate of the same quarter of the previous year to project the data into the future, other than for social contributions, which, if I made this assumption, they should not be seasonal. They had this jump here. This is because nobody was working, and therefore the base collapsed, but now they're back to roughly stable level. So I don't see seasonality in the last period, so this one is okay. Now, how do we do this in BIMETS? And the answer is we can do it in different ways. I haven't saved this code. So first way, I'm not sure that I have it in here. No, I don't have it in this file. So let me, I don't think I want to save this. This is again a file that I may not have shared with you already. Yes. Yes, here it is. So BIMETS has this command, which is TS extend, to extend a time series into the future. So the point is, it's less flexible than eViews. So you have to specify the variable to be extended and the last period for which you want the data to be extended, and then the type of extension you want to make. Now, these extension mode are a little complicated. So you can have 0 if you want the variable to be 0 for the future. You can have constant if you want the variable to be the same as in the last data point. Growth for if you want the variable to grow at the same annual growth rate it had before. And I think that more or less this is it. So the problem is that you have less, or here you also have missing for the exogenous. Yes, we also want to extend our endogenous variable to be available for the future, because when R computes the simulation for the future, the data frame must be long enough to store the outcome. Now, the other thing which made me mad is that you have to do all of this before you load the data into the model. Otherwise, when you simulate the model will use the short sample for the data and will refuse to give you forecast for the future. So my previous code that maybe I shared, I was first simulating the model, then extending the exogenous, and I had an error, and I was not understanding why I was getting these errors. So all of this should be placed in our code before we load the data. So here we have finished creating model variables, and here we can place the extensions. I think it should be okay because these are all referring to the MSFC model data, and therefore it should work. The other possibility, which I think is more practical if you want to do this with R, is to prepare everything in a spreadsheet before. So if you, in the spreadsheet, you arrange your variables so that you have the exogenous separately from the endogenous, and you set up the routine in the spreadsheet to compute the future values as you think is most appropriate, then you don't have to extend them in the R code. Also because, for instance, now we made some projections for Greece using the money that Greece should get from the European Union for the Next Generation EU funds. And there we have these millions, which will come every quarter of 2022 and 2023. So we cannot simply extend a variable like this, but we want to extend it quarter by specific amounts. So it's more complicated to do this with this TS extend command. So let me check whether this works. I saw something red. For D4 part D, yes. Yes, because the options that are available in BMETS do not include a yearly difference, which is what I wanted to use for this type of variables. You only have the growth rate, the annual growth rate. So in order to extend a variable using annual time differences, I created additional variables, which are the time differences of what I want to extend. And these are basically this D4 part D. No, sorry, it's not here. Okay, so these are these additional variables that are simply the yearly time difference in these exogenous. So I need to copy this from here and paste it where we have additional variables in here. And I have to add the additional identities linking the value of, let's say, tau dt to the value of the previous year plus this additional variable, which is its yearly difference. And I did that somewhere in here, maybe at the top. Yes, annual difference. So these are the identities I need in the model only to be able to project my exogenous later. So now we have fixed this problem. So let's see whether everything works up to here. Why is this not scrolling? So I have a number of warnings because not all variables are available for the whole sample, but I think everything worked. So we have to estimate the coefficients. Everything worked. And now we can simulate the model. And this is where we cross our fingers. We want to simulate the model up to 23 fourth quarter, because now we should have provided the values for everything up to 23 fourth quarter. We forgot to extend the dummies and the time trend, I think. Okay, so
there should be a function that, so basically here what you're doing is applying the same function ts extend to every variable in the data frame, right? To all of them.
Yeah, but with different methods.
Okay.
But I could group those who need to be extended with constant and those who need to be extended with anyway, I forgot to extend these two dummies. And this should be rather straightforward. So these are the 2020 Q3. And this should be 0. Same for 2020 Q4. So we fixed this mistake. Okay. Let's try the simulation. trend. Yes, we also have trend, but I think we can, when we define trend, instead of having it in up to 60, we should be able to extend it up to wherever we want.
You can extend it to, you can make it like some sort of depending on the length of another object. So that it will always, will be along as much as the other one.
Yes. No, I'm just thinking that right now, the model data stops in 2021 Q3, but after the extension, it will be larger. So maybe it's a good idea to shift this to a later section of the code, where now everything in the model data ends in 23 Q4, and this implies another nine observations. So I hope that this will extend trend up to the end of 2023. So let's check. Something went wrong. Okay, I think we had errors before. So what this is saying is that these D2020 Q3 were not yet defined.
Spelling mistake.
These are defined here. So let's run the code up to here. Okay, now this is a problem. But this did work before. I don't know why it's no longer working. Oh, because this relied on trend. Yes. So this was based on trend. Now I've moved the trend definition to later. So I cannot move this to later. So let's move this back to where it was. Let's see whether I can run this up to 69. Yes, okay. So now this should be okay. And now we check whether we can extend everything. Okay. Load the model, the data into the models, okay. Estimate coefficients is okay.
You know what, Gennaro, we can really simplify all this bunch of code, which is the same, with one line. We can do with, we can make a test first. We can do, save everything in an object called MSFC model data, but one, so that if it was broken, then sapply, we can use the sapply function. So with one line, we basically repeat all the same.
Okay. Since this is working, let me keep it for the time being, and then we make the change. So let's see whether now we can do the forecast. No, it's still missing something. And the error I get is for BP, but I'm pretty sure the error is somewhere else. So what we should do is to check model data. If I look for BP, BP is endogenous, so you should not need the variables for, should need BP to have values after 2021 Q3. But it's complaining that it doesn't have values for this period. So it's a little weird. Anyway, we can try this quick fix. So instead of having missing for the endogenous, as I've done, we could use constant. So let me replace all missing with constant.
What is it doing now?
Well, as I said, BMETS wants all variables in the model to run until the end of your forecast period. So it wants you to have extended not just the exogenous, but also the endogenous variables with some value up to the end. Obviously, we don't know which value the endogenous will take. So I've just given them some stable values.
So constant means just this stays the same.
Yes. But as I said, I don't think that this is the real problem. Now it is missing D4 tau. But this is defined to be 0. So these are all defined. So I don't really know where the problem is. Okay. Anyway, in eViews, I've done the same for all the variables which are exogenous, and this works. So what I can do is to look, let's say, at GDP in the baseline, and I can check this is the last data point, and to the right these are the model projections. So here I can place in the chart a vertical line to separate the historical simulation from the forecasts. Okay, so let me have a short break because I had this problem before, and my friend and colleague apparently solved it. So let me check. The impact of a shock. Let me close some useless windows. Let me get back to my shock. And here now we want to shock the variable into the future. So 2022 Q1. And we now can add, instead of a fixed value, I can add to government expenditure 1% of the simulated GDP for the future. And now we want the simulation to go up to 23 Q4. And now we can look at GDP K with the additional government expenditure and against the GDP in the baseline. And now this is a better estimate of the short and long run multiplier of fiscal policy. So you can see that when you do the shock in this way, the long run multiplier is roughly similar to the short run multiplier, which is what I would expect in a model which is so simple. Okay, one thing we didn't look at is the stock to flow norm. Should be one of the variables we're interested in. So this was stabilizing here, and it has been increasing from 2018 onwards. So if we want to improve on the model, we should have some other determinants of why this has been increasing, then stabilizing, then increasing again. Okay, so I suggest we take another first afternoon break. I think that even if there is no one online, well, the recording is going on, so I will still share my screen on Zoom so that it will appear in the recordings. So we want to have employment in order to have a measure of the wages. And let's look if this is available in the OECD database. Because we should have also a measure of employment and unemployment. Yes, and here population and employment. Not entirely sure we have unemployment, but let's check. The OECD database is very slow.
Pretty bad. Yeah.
Okay, so Let's customize our data set. Okay. So subject. Used to be much quicker. I don't know what happened to the OECD. And yes, we don't have unemployment here. It's funny, we have the total population, but we don't have the labor force. Never mind. Let's extend the period. So 2007, take 2006, just to be sure. Customize the layout. And we want the data to be in columns, subject to be, so this should work. Come on. Okay. So this is what we want. We don't want the seasonally adjusted figures, so we can download it. So here we have the total population, total employment, employees, and self-employed. Maybe we need all of this. And I think the best way to proceed is to update our existing GDP data file. So let's do the following. Let's open our GDP OECD dataset. Starts in 2007, and I'm copying the data from 2007 to the last available quarter. I'm going to paste them in here. And we have to provide some variable names. So this could be POP for population, and EMP for employment. And then we have employees and self-employed. So let's call these MP workers and MPS for self-employed. And just to avoid confusion, let's call this file in a different way, GDP2 OECD. And we also wanted the exchange rate of the peso. Now, maybe it's quicker if we look at this from the Federal Reserve. Hopefully it's quicker than the OECD. So here we have data, and where are the exchange rates, foreign exchange rates. And the data download should work. So we can build our package, foreign exchange rates, countries, Mexican peso, frequency monthly, the format package. This is already from 1993 to present. So I think we can download it directly. Observation, I thought it was already selected, but let's choose the dates. So from 2006 is always easier. January to 2022 January. And let's choose Excel. Download file. And this is it. Okay, so we have this additional data file, but the problem is that it's in monthly frequency. So I'm pretty sure that we can work out, Alessandro can work out how to download this in R and use some time series thing to change the frequency, but to me it's much quicker to do this in R. So I'm going to create a new page for monthly data starting in 2006, month 1, ending 2022, month 2. And here I can create a series called XR for the exchange rate, which will be empty. I allow for editing the cells. Now I can copy the data from Excel and paste them into eViews. And then I can copy my series from the page. This is called Untitled. Okay, copy from Untitled series XR to the series called, the page called Q, using average for conversion. So I now have in my Q data file, my Q page, the series XR, which is the average from 2007 to present of the exchange rate of the peso. So I can copy this from here, go to my GDP file and paste the data, and let's give a heading XR. So now I am saving this new data file in here, and I'm going to save it also in our shared folder. Okay, so data collection is complete. Don't know why Excel has crashed. Yeah, we have to Excel. My Excel is crashing all the time, so I'm trying to avoid it, but it's not something you can easily do.
Yes, you can.
Huh?
In R, you can do everything without.
In R, yes, in R you don't have crashes, but in Excel, every time I download data from these websites which have links to external sources.
Yeah, the XLS, so with this
Yeah.
links, yeah.
Yeah. So what do we need to do with our model? We should have already, we wanted to have a measure of wages. So in our data file, let's go back to our data file for GDP. It should not make our computer crash. So here we had the CE, where compensation of employees. So this is already available in our data set. And we can divide CE to the employment level to have a measure of the average wage. So let's do that. And well, let's do this directly in R. So now we have this file called Mexico 29, which was working. We were happy, and we don't want to lose the result. So I'm going to save it with a different name. Let's call it Mexico 29B or 29X extended. So first thing we want to do is to extend the data set to include the other variables in the GDP-D. And this should imply that when I'm here, I have all the new variables included in my MD data frame. So if this is true, here I should be able to write MD XR, but I don't have XR. So something is still missing. Yes, I need to specify GDP2, OECD rather than GDP. So let's try again. Problem with ID.
Yeah, probably it's been defined later.
Maybe I didn't have
It's not included in both data sets.
okay, let's look at what I had in the last version of GDP that we shared. Now, this is my private drive, while this is our shared drive. No, I didn't have an ID in here.
Maybe we did include it in our talking Excel. Yeah, there.
Okay, but why is this not available now? Is this still 59 observations? Maybe look, now we have 60, 59 observations still. Now we have also this data, this additional data.
Ah, okay, made it longer.
Yes, so I need to have NAs in here. I hope this is not going to create other troubles. So let's, now this should have another 2 observations. Okay, so let's see whether we have XR. Now we do have XR. Okay, so everything is okay up to here, and here we are defining our model variables. So I think it's safer to move to the bottom before we start with the model and add here the additional variables for the extended model. So first thing is we want to compute wage, and this will be the ratio of the compensation of employees to employment. Okay. Then we may also want a variable for productivity. And this should be the ratio of GDP in real terms to employment. Then what? Then not sure that we will be able to model population, but let's see what else we want to do. So how do we want to model distribution between wages and profits? So right now, CE is not part of the model variables. It's nowhere specified. how the income from production is split between wages and profits. Okay, so we do have net indirect taxes taken out. So one possibility is to look at the share of profits over value added, so the profit share, and see how it moves and whether we want to try to endogenize this or keep it as exogenous. So how do can I plot these things directly? Maybe to me it's always easier to work with eViews, but I should modify the eViews code as well. So if I want to plot a ratio, can I do it without creating an additional variable? With plot?
With plot or with plotly?
So with plot, I just type, this would be MD dollar MD dollar CE over MD dollar GVA. It's not GVA. Oh. Now I have a problem with the placing of these consoles. Can I move this console to the bottom here again? Or this is going to make a problem. So do I do this here? Console on left. Yeah, I think I need to do that. So there is this problem with the COVID. The GDP drops while they kept paying wages. So we had this huge decrease. How do I transform this with lines?
Let's say comma,
Type.
Equal, quotation mark, L.
L?
Yeah.
Okay. So this seems to be seasonal because GDP maybe is more seasonal than the compensation of employees. And then we have these crazy data for 2020. But yes, we could try to have this stable. I don't understand what happened to, it's called GOSMI, the gross operating surplus. So one way to go, well, let's see what are your suggestions. So we now have GDP, we have value added, we have profits, we have employment. GDP is determined from the demand side, and we want to endogenize wages and profits. So what are the options? Obvious option is to say the share is constant and exogenous, but this is not, endogenizing things that much. Yeah, I think you are on the right track. We make employment a function of output, which is standard in the Keynesian models. So we want to verify, and I'm not sure how easy it is on R. Basically, we want to have a estimate of LM. Now, do I have the tilde here? I don't think so. Oh, again, I have to look for a tilde, but we want to have a regression of employment against well, R should include a little button to obtain the tilde. So amp, but amp should be MD dollar amp against output. And I think we will get the constant automatically. Okay, so these are positive and highly significant, but we will want to look at the residuals. So how do we plot the residuals? I guess it's plot and should be reg residuals. So the residuals are not well behaving and they are shooting up at the end of the period. So let's try adding the lagged value of amp, or maybe we can try. Can we directly take the log here?
Yeah.
Log of amp against the log of GDPK, and let's add the log of amp. But we don't have the, in LM we don't have the lags. But they said it was using another formula here, so let's try whether this works.
I think the EFP is DYNLF, which is the dynamic version of PFLF.
I'm sorry? So this has worked.
Okay.
But this lag is not significant. So not sure how well the data will, these estimate will track the data. The other thing we may want to do is to check whether there is any relation between wages and real wages and employment. We usually don't want to have that much evidence in heterodox modeling of employment, but it's worth looking at it. So let's drop the lag and have MD. I think we defined this the wage. So this should work. and wage is not so significant, and it has the wrong sign with respect to mainstream economics, because the employment should be negatively related to the nominal wage. Let's try the real wage.
I think you can do the math operation inside. You know, might be.
Okay, let's compute this new variable called real wage equal to the wage divided by the price, but it doesn't have ppx.
Okay, then maybe that's a problem.
But I thought that I will place this at the bottom. So here we do have ppx. Okay, so let's run everything up to here. Why is this no longer working? Okay, because now we have 61 rows. So we need to change all the 59 to 61. So let's try again. In the loop 6 to 59. Not sure this is going to work because we have some missing at the end, but anyway, let's try. No, it still doesn't find MD. These are, yes, this is because the other file still has a smaller number of rows. This is why I wanted to transform everything to time series, because with the time series, you have this time index, which makes it easier to match the different sources. But anyway, let's keep it like this. So now in here, we are defining the data frame max. And this is giving a mistake because it doesn't have 61 rows. So this is should be 59, right? So let's look at the max has been destroyed here. It's 55 observations. So we should go to 55. Well, it was not 55 before, I think. It was 59. Oh, yes, because it starts later, so it's 59. Okay, so now I created MD. Now all this should work. Let's look at the loop. Okay, seems everything is working. Okay. So we have everything. Now we're playing around with the equation. And now this worked.
Okay. So the problem was the PPX, right? So that were,
Yeah.
we didn't need the one.
So if I use the real wage, we do have the mainstream result that higher real wage is associated with the lower employment. I don't particularly like this, but let's see what happens if we use this into the model. So in this way, we will be endogenizing the level of employment with respect to the level of output and the real wage. So if we want to put this into the model, let me copy this and let's go to the code. So in our code, we move to the bottom and we want to have something like this. So comment will be employment. The variable is emp. The estimate, I think, is 2008-1, 2021-3, and the equation is the log of EMP. Here, the parameters will have to be different. Here we have the log of GDPK. And here we have the log of wage over PPX. And here we have added this variable wage, which is not specified in the model. So we have to add the identity. And this would be wage. And we said that the wage is given by CE divided by AMP. So one way to go at this point is to keep the wage determined somewhere else and define the wage bill, compensation of employees, as determined by the level of employment times the wage. But this is making this identity useless, because this now implies that wage should be exogenous, and we instead estimate employment, and we want also to estimate the wage. So the other thing which was missing was these gross operating surplus. Now, I don't remember again how I called this, but it should be in MD. Gross MI. So gross MI given CE, gross MI is also determined. From the difference between value added and the wages, compensation of employees, and I hope that this GVA is also in here. Is it? Yes, GVA is here. Okay. So next thing to do is we wanted to check whether we could also model the wage. And how do we want to estimate the wage? So let's look at what happens if we link it simply to the domestic price and the foreign price. So this is highly significant, as I would expect, and this is not significant. But do you think this is a good idea to have an equation for wages in nominal terms determined by the current price index? I don't think it's a good idea, because prices will depend on wages in the same period. So usually you want wages to react more slowly to inflation, and inflation reacting more quickly to wages. So we could have a different equations, which is the growth rate of wages, wage inflation. How do we compute wage inflation without using time series? Because these MDs are not time series yet. So
we have to append one bar, create first of all the empty space, the variable that we want to create as before, and then we use the lag operator and the diff operator.
Okay, so let's do this in the code. And in the code where we create the variables.
Yeah.
Okay, so let's do this in here, but after this, so it's something like this in principle.
Yeah, but I think we don't need a loop.
Why not? You have to create a loop because you have to, without the lag operator, you say it's not, we don't need the loop.
I will show you another way to create variable if you want.
Okay, so let's try this out.
Yeah.
So let's call this wage G for wage growth. And this has to be given by wage in the current period divided by the lag of wage with 4 lags minus 1. Looks like it did it. Let's look at the outcome. Oh, I need the brackets here, don't I?
Yeah.
Okay, so it worked. So let's also create the inflation. Say it's infl, and this is ppx divided by the lag of ppx 4 quarters. Yes. Okay. So let's try again our function, which was instead of wage, we have wage growth, and instead of ppx, we have the lag of inflation. And let's keep this out of the picture to begin with. Close the log, close the lag, close the ln. It's just okay, now these are growth rates. So we no longer want the logs, because the log of growth rates will not be there when the growth rate is negative. And this is very reasonable, but this is wrong, completely wrong. There's a negative connection. There's a negative connection between inflation in the past period and the wage growth. Let's check whether we can improve this. I mean, we will work on this until we are tired, but this can be a lengthy process. So let's also compute the growth rate in productivity. Now we've done that. And let's also have the lag of productivity growth. And now we have basically nothing. Yeah, I think the R square is 0.04. Let's look at the residuals. and they are dominated by this dummy here, which will be the, I guess, the 2020 Q2 or Q3. So I think we do have this in MD already. No, okay. So we first need to create the dummy. I think that this should be okay. No, because this is referring to model data which has not been defined.
We have to do it in MD.
Okay, so.
But you can copy and paste those lines and I think it will work.
This line?
To create a dummy, yes, we have to adjust it.
Yes, which is the, in MD we have 61 observations. So we want MD $D 2020 Q2 equal to if else what?
How do we call it? Trend.
I'm not sure we have trend defined.
I think we will call it ID.
Okay. So if else MD $ID equal to, so now 61 is first quarter of 2022. So it should be 58.
Equal.
Okay. This should be 59. So let's check what happens if in our equation we also had this dummy. And I think nothing relevant has happened. Let's look again at the residuals. Oh. So we still have this up here. So this must be for the fourth quarter instead of the third quarter. So let's create another dummy for the fourth quarter. But still, we are unable to get rid of this thing here. What if, how can we stop the regression to a given number of observations up to? So we want to drop from 57 to 61, we want to ignore them.
From 67 to?
We want to drop the last 5 observations, 10 observations.
I will do like this. In the LM function now that we are using, we call for every specific variable the data set. I would like that comma at the end, data.
Data.
Yeah, equal MD And now we remove the rows that we don't need.
Mhm.
So it would be open square brackets. And which number did you say? I forgot.
Now, let's start from 5 because the first 4 observations are missing. And instead of stopping at 61, we want to drop the last, say, 9. So it would be 52.
Yes. But exactly. And then I think in the reg, we have to.
Anyway, this is still didn't work. Actually, we can no longer have this one.
You can also remove D and D, but that doesn't really matter.
Yeah, but anyway, this is getting us nowhere.
Yeah.
So, so far, I mean, we're gonna spend quite a lot of time. And I would say that it's better to keep the wage inflation exogenous for the moment and try to work on a price inflation and see what happens. So what we could do to achieve that is we want to add we've done this when we go to the model. Okay. So what else we've done is to have the nominal wage, and this is determined now by its growth rate. Okay. Does it make sense to try to solve the model at this stage? Because we have not actually, we have added only the employment equation in here. What we will need to do is to extend these new variables with something we have not done yet. So the new variables are emp wage I think we also need CE and GOS MI. And what else? Wage G. And that's it. I think so. I think these are everything we need. So let's check if everything works up to here, and let's check how much the behavior of our model has changed with this additional equation for employment, which was not that good. These all worked. Now this should still be correct, I hope, for 51 and 56. Okay, so everything worked. Estimate seems to be okay for all equations. So now we want to simulate, but we don't want to have the projections yet. So we want to simulate up to 2021.3. And we want to plot the outcome in terms of NAFA W was our control variable. What now? Now we have more than 51. Site 60. I think I need to update the X to go to 60. Now the simulation is not only 50. So what if I have this from 10 to 60? No, it's just shifting the problem somewhere else. This is still a problem of the reference time periods because I'm trying to compare these MD dollar NAFA W, and this is not available for the last two periods. It starts in period 5, so this goes from period 5 of the data to period 59.
But I think that here in the plot, you can just say from 1 to 61. And then
No, but 61 should not be there.
But if the data is not there, it will simply not show. But the two, the X and the Y, must match.
Okay, but can't
The plot at least.
why I cannot give from 6 to 59 for the first one, this NAFA W, instead of saying from 1 to drop 1 to 8, can't I say from 6 to 59? Is this going to work?
It should. Let's try.
And how many numbers do I have here?
Again, try it as well from 6 to 59, also as dx.
Okay. While the simulation, let's look at what do we have in here. For a NAFA W. Now, this is a time series. So 61 is going to be 2022 quarter 1. but I'm not sure how this is indexed.
You can measure with the function length how many things you have inside this MSFC model simulation. So length, and the inside you look exactly.
Length TH.
550. And then in order to make it really adjust every time, you do X, the arc trace in the arc trace of the core of the simulation alpha. You do from 1 to the length. So from 1 colon length of basically the variable. And you should simply just
to length
exactly
of this whole stuff
of
in
the
here. Or I can just type Y.
No. The full stuff you have to type, unfortunately. Yeah. I think it should work. Yeah.
It did. But we have some problems in here because this should be shifted by 8 observations or something to the right. Now we're comparing data. You see that this thing here should appear in here.
Right.
So this should start not from 1, but from 6. So
I think that both of them should, so both axes should be the same. So from 1 to the last, right? I don't know what you want to.
well, the problem is that they are indexed in different ways.
Okay. Yeah.
So now we're taking some observation from the first data set, compare them with the observation in the second data set that's shifted. So, this should be shifted onward. And again, if we had the same time index, it would be easier. But now we have indices which are not matching. So we don't really know what to do here. Other than using, I don't know, can I use a lag here? I don't think so.
No. So we need to have the same from 6 to, I've lost track of how many in the second trace.
Yes.
The X should start from
from 6 again.
Okay. And then should go to the length of the simulation alpha is 50.
Minus 5.
I think 50 minus, okay. I believe you should put this in parentheses. And parentheses there, close, and one that begins after the semicolon. Yeah.
Okay, that's right.
That's right. Match.
40 and 50. Now I have to restrict this. I don't know what this would be for. But what if I create NAFA WS given by my SFC model simulation NAFA W, and the other thing I want to look at is the model data NAFA W. So let's call this NAFA W D for data, and this has to be model data $NAFA W. So now I can look at the two NAFA WS. Sorry, it's my EViews syntax, but this still is. So now they're both time series. And this one has been extended in my extend comment. So I can now probably compare them. This starts in 2009, quarter 2. This starts in 2007. So what I want to do is to have this NAFA D, what I now call NAFA D, so NAFA WS starts later. So NAFA WD should start from observation number 9 until I think it's 61. No, it's 59. And this NAFA W is now what I call NAFA WS. And this starts from 2, I think, or this is 1. Maybe this is 1. This should also be from 9.
I think it's 2 because there is an NA. I believe.
No, it's not an NA because
Okay.
NA should appear.
Okay.
Let's check whether this works. Add trace. NAFA D not found, but oh, it's NAFA WD. So we've not lost all hope.
Yeah.
Still one missing. So you said that the first one, or maybe we need to restrict the X rather than the Y. No, I give up. I need another break. But we really want to have a data frame which is a time series data frame, because that would make our life much easier than now. And it should not be too complicated to get there. Okay, so let's have another break, cigarette break for me, whatever for you, and then we decide what else we want to play with. But I also wanted to replicate what we have done in here. So this is the employment equation we've added. And if we look at the residuals, we can see that we are clearly missing something that starts in 2018, and implies an increasing residual in the last 4 years or so. So there must be something which is affecting the employment level that is not explained by the model and will create a large discrepancy between the model simulation and the data. So also this is suffering from autocorrelation, this strong autocorrelation in the residuals, which is another sign of some missing variable. I have no idea of right now of what this can be about. We could look at the share of employed workers on the total. So let's look at the employed workers over total employment, just to see whether there's any trend, but this is only affected by the pandemic here, so this is not going to help us understand the movement of employment. We could look at, I don't know, let's look at what happens to exports related to GDP. It could be another source of changes in the employment level, but again, not sure that this is going to help us that much. But we could try to add this as an additional explanatory variable and see what happens. And this is slightly significant, but it's not solved our problem. Let's look at whether we at least remove the autocorrelation using the lagged employment level. Still, I don't think that we have obtained a reasonable estimate. Finally, we can try to take away the second quarter of 2020. And now, still, I don't think we have fixed everything. Yes, we still have these residuals increasing in value from somewhere around 2019 to present. And we still have this seasonality in the residuals, but only in the last part of the sample. Now, I don't know what happened in Mexico, and this is the big problem. Let's try to add also the fourth leg of the dependent variable, but this is not significant, so it's not going to remove the seasonality in the residuals. Last thing we can try is a structural break. And here, is something I always tell to my students. So if you look at the results you have in the sample, it seems clear that your model, the model is explaining relatively well from 2010 to 2018. It's not working well during the Great Recession. It's not working well after 2018. So we could try to split the sample in 3 parts and estimate the coefficients separately in these 3 parts. But what I tell my students in my first class of econometrics is that if you look at the data and you set the model so to replicate the data, you are just, feeding the right answer to the model, and it will be the outcome of an arbitrary choice. So what you will want to do instead is to look for some breakpoints that are not arbitrary. So if you introduce this routine to check for this, but this will ask to remove the, these dummy variables, because this routine will estimate the model over subsamples. And if you have a dummy, it will make the matrix singular. So without the dummy, we can try this multiple breakpoint test. And this is suggesting that 2019 is a breaking point, and 2014 is possible another breaking point. 2010 is another breaking point. So these would allow us to use a structural break, which has not been identified by our own judgment, but by the search for the best way to split the sample in order to pass these structural stability analysis. And we can do that by adding a variable that in use is called after 2019 Q4. So this will shift the intercept after 2019, but we can also check whether there is a shift in the parameters by doing something like this. So basically, this is a test on whether the coefficient of GDP changed after 2019 with respect to the previous period. So the test is significant, and it's saying that employment reacted much more to GDP, actually doubled the link to GDP, the elasticity with respect to GDP after 2019. And we can also check the same for the wages by multiplying this by the real wage variable. And this is again saying that the elasticity to the real wage is doubled in the last period against the previous period. So with these changes, we can check the behavior of our residuals, and now they are no longer trending in the last period. We are still missing the previous period of the sample, but this is usually less important when we are interested in doing projections, because for doing projections, we want the latest period to be well tracked. So this seems to be a much better answer. We still have this feature, which I don't like at all, that the employment reacts negatively to the real wage, but we'll have to live with it. So I think we can also apply this into R, pending our search for the use of everything as time series. So if we want to add these, let me check where we define the dummies. Okay. So as we define these dummies, we can define a dummy for 2019 Q4, and this will be a break dummy. So usually use a B, and this should be an if-else MSFC model data trend is larger than 2019 Q4. Now, if 2020 Q3 was 55, it should be 49 or 49. Am I right? And we want to do this. I'm going to copy this for this new variable, data 2019 Q4B. Okay, so let's look at it. And no, I was wrong. So this should be not 49, but 51. Let's look at actually 2020. Oh, that is not defined. This is correct. Okay. Now we also want to extend this later when we run this. So this should be 19Q4B, 19Q4B, and this should be constant to have once. So now this should be fixed, and I can try to add, where is the model? Here is the model. So I can modify my employment equation and use the same structure I have here. And I'm going to have a much longer list of parameters. So this would be the TS lag of the log of amp plus these 4 times this dummy plus fifth parameter, which is this one, times the log of GDPK, plus a sixth parameters, this times the log of wage over PPX. And here I have to add this other parameter to the list. There's 6, yes. Okay, so now we should have the same model in R and eViews. And now I can solve my eViews model. And this is 2009 to 2021 Q3, and look at whatever variable we want to look at compared to the data. And we are still getting a large discrepancy in estimating the balance of payment, but it's not so much worse than we had before. We still need to have something that explain this fall. The other thing I wanted to look at, which is quicker to do in eViews than R, is to look at which variables are still exogenous now that we have endogenized the compensation of employees. And still have the price level, which is exogenous, and wage growth. So let's try to play with the price level. So first of all, let's define, as we have already done in R, the series called inf for the growth rate of PPX. And let's look at, I think we have wage growth. Yes. So let's look at wage growth against inflation. I usually find it very interesting to look at the XY lines, because in EViews you can restrict the sample very easily. And what this is saying is that apparently there is no relation. So there was a relation from 2007 to 2012, which is what we expect. To a higher wage inflation, you had higher price inflation. But after 2012, there was a drop in inflation, which was not due to changes in the wage growth. And after that, you had an increase in wage growth without increase in price inflation. And then in the last years, again, it looks like you had a crazy movement due to the COVID. So first part of the sample, there is what we expect to have, higher wage growth, higher inflation growth. Second part of the sample, no relation whatever. Last part of the sample, COVID crisis. So this is not going to help us very much in trying to explain the, Yes, now we do have the exchange rate. So let's look at the exchange rate to the dollar. And we can look at the annual change. But again, it's not so easy to interpret this against the evidence. Let's check whether the change in the exchange rate over the previous year is correlated to the change in import prices over the previous year. And basically, this is saying that most of the change is due to changes in the exchange rate, meaning that the change in the import prices in dollars was very small. So most of the variation is due to the exchange rate. So this is very helpful because it suggests that we should be able to link the changes in this relative price also to the exchange rate. So now the orange line is the change in import prices relative to domestic prices, and they can be modeled with the exchange rate changes. From some point of view now, these are relative prices now exogenous. If we link it to the exchange rate, we will be endogenizing it, but with respect to the exchange rate, which is exogenous. So we are not adding that much unless we can explain the exchange rate. Okay, so the only thing we're adding is another error in determining the relative price, which may not be exactly what we are looking for. But let's play a little with an equation for inflation. And the other thing we may want to do now that we have the wages separate from profits is to look at consumption separately from investment. So here we already have consumption in real terms and nominal terms. So we can define a new price index as the consumption deflator. Sorry, series. So we can look at these two price indices and check whether how they are moving. And this is showing this should be much easier to model the more common consumer price index. Now the blue line is the consumption deflator. Well, the orange line is the deflator of both consumption and investment. So this means that the deflator of investment goods is much more volatile than the deflator of consumption, which is usually the case. And I also suspect that the deflator of investment goods is estimated less precisely in the national accounts. So these may help us improve a lot the modeling, especially if we are better able to find a connection between, let's call the inf C, the rate of growth of the consumption deflator. Sorry. So let's now look at wage growth against the growth rate of the consumption deflator, again with the XY line. And again, here we have this craziness of the last periods. So once we remove the pandemic, now we do find a positive correlation, which is much better. So here now we can try to have an equation. Which equation we were working with? None. Okay, so let's try an equation for what I called inf C against wage growth. In principle, we also want the growth rate in productivity. And we may want to have the lagged value of inflation to begin with. And now we have something funny, which is this negative value, but we saw that the pandemic made things completely different. So let's start to estimate this up to 2019. But still, when we include productivity growth and the previous inflation level, the link with wages is completely lost. So what if we drop the previous inflation level, and now this is mildly significant, but we have autocorrelation. This is no longer significant. We could try, we could lag the wage, or we could, let's compute also productivity growth. And the standard idea would be that we have wage growth less productivity growth, but here we have really nothing. So we can try by lagging this as you just suggested. And still we have a negative link, which is not what we would expect. And I fear that if we also separate this, we still get this negative link to wage growth. Now, let's try the other determinant of inflation, which is import prices. Still in growth rates. But still, we are unable to explain what happens. And probably the problem is that the actual values are moving more than the determinants that we are using. So this is getting us nowhere. When we add the lagged inflation term, this becomes significant but with the wrong sign. This is significant but with the wrong sign. This is not significant but with the right sign. So yes, we are explaining something, but doesn't make any sense in terms of economics. So this is saying if the wages go up, they reduce prices. If productivity go up, they increase prices. It should be completely the opposite. Yes. So maybe the wage variable we are using is not the right variable on which firms base their pricing decisions, because we took the total wage bill divided by employment. But we know that in Mexico, a large number of people may work in the informal sector as self-employed, and that is going to affect our measure of wages. So I don't really know what to say. We could try adding the exchange rate. Huh? Commodity prices. Yes, but they in principle should influence the price of imports that we have used as an explanatory variable.
Maybe there's a lot of tradable goods and wages and productive term are so important.
Yeah, that's a good suggestion, I think. The import prices. Okay, let's try this. But the other thing is, I was using maybe the wrong leg. So if I only use the growth rate in import prices, I'm not explaining anything. The only thing which explains is the lagged value of inflation. I think if we add the current wage growth, still not significant, but at least it's positive. And I could try the wage growth of the previous year in the same quarter, but this is again, say nothing more than what we already knew. So at least this is going to give us the expected impact of wages on prices, but the equation is pretty bad. It is following the data with a lag of one period because the main explanatory variable is lagged inflation. So I'm not so sure that this is going to help us explain what happens in Mexico.
I forgot why we wanted to begin to model inflation to begin with. What was the motivation to include inflation?
Well, if we include inflation, we can try to endogenize relative prices and therefore explain trade better. Okay. And also, since now we have the wage as a determinant of employment and the wage bill, if we have also the price level, this should complete the specification of income distribution in principle. What we could try to do is to have some more sophisticated treatment of these variables. So if we look at the index of prices rather than the growth rate, I'm not sure what sample we are using, but I guess that this will be up to 2021, this is a non-stationary variable. And if we test its first difference, is stationary. So this is suggesting to use co-integrating techniques. So we could look at the log of the wage and check whether this is stationary in differences and non-stationary in levels. So we could try to have a co-integrating approach and see whether it is any better. And one way to go would be to have the so I don't think that this is very should not be very seasonal. So let's look at whether wages are quite seasonal. So one way to try to model this as an error correction mechanism could be to have the the log of PC divided by its previous period. This should be the same as the growth rate of prices against the lagged level of prices and the lagged level of nominal wages and the current growth rate in wages and the lagged inflation level. So in order for this to work, this should be highly significant. This has the right sign, but these two are not significant at all. And the only thing which is significant is this lagged inflation rate. And again, if we estimate this up to 2019, things do not improve at all. So basically, our simple idea of how to model inflation fails completely with the data for Mexico. I must confess that in the living models so far, we have not modeled inflation. And this is because inflation in the last 40 years at different periods. So it was small in the 60s, then quite volatile in the 70s. In the 80s, most countries started to have these neoliberal policies to fight inflation. So inflation went down and had very little volatility. So when something has a little volatility, it's very difficult to explain how it is changing. And the other thing is that before the 80s, the wages or the unit labor costs were quite strongly correlated to inflation. But in many countries, this broke down with the neoliberal behavior. So you no longer find that nominal wages or the unit labor costs are in line with the price inflation. So it has been very complicated to explain inflation in this period. And now inflation is back, but it's back mainly from foreign prices and commodity prices. It's not clear whether wages are following. So in some countries, like the United States, it seems that they are starting to increase in line with the prices. Some other countries, I don't see an increase in unit wages following import price increases. So again, it's very difficult to think that you can fit an equation for wages and inflation over these 20 years using the same variables. You really need to want to have different models to explain the different periods, which means that for our little experiment, it doesn't seem easy to endogenize inflation and endogenize wages. So for the time being, I leave things as they are. What we can surely do is to see whether the model can be improved by looking at our private expenditure function, and we can check what happens if we estimate instead a consumption function using the same determinants but the price deflator. And well, the R square, sorry, this is something missing here. Okay, now we have a problem which is the same in both equations for the significance of wealth, but we found how to fix the problem earlier. And it looks like the consumption function is slightly better than what we had for private expenditure. So here, yes, we were using these two dummies for fixing this, the effect of the corona. Where the third and fourth quarter of 2020. And this gave us a positive coefficient for wealth. And the same happens here. So basically, from the summary statistics, it's not very clear that we get a much better fit if we move from the private expenditure function to the consumption function, because the overall significance is smaller, although we are comparing two different variables. And the feedback of the stock of net financial wealth is even smaller than what we had here for private consumption, for private expenditure as a whole. So this is something we can do. Is useful if we find a good investment function, but I'm skeptical that it will improve considerably the ability of the model to replicate the data. Okay, so we, I think, can stop here for today. And